Good day everyone, my name is Coolen Ramos, 29 years old, a BSed Mathematics 3rd year student at City College of Calapan. For today's tutorial, we are going to tackle about the improper integral with lower limits.
An improper integral with a lower limit typically involves integrating over an unbounded interval or a discontinuous function. Unlike standard definite integrals, improper integrals may not have a finite limit. The lower limit extends to negative infinity or approaches a point where the function is not defined. Dealing with such integrals often requires special techniques or limits to determine convergence or divergence.
In solving improper integral, there are three cases, but in this video, we are going to focus in case number 2. It states that if f is continuous for all x is less than or equal to b, then the integral of f of x dx from negative infinity to b is equal to the limit of integral of f of x dx a to b as a approaches to negative infinity. Example, evaluate the integral of dx over the quantity of 4 minus x squared from negative infinity to 2. So, the first thing we do is convert the integral to a limit. So, the integral of dx over the quantity of 4 minus x squared from negative infinity to 2 is equal limit of the integral of dx over the quantity of 4 minus x squared from a to 2 as a approaches to negative infinity. We do the integration and the limit. In this example, we use the u substitution. Let u is equal to 4 minus x and du is equal to negative dx. We divide both sides by negative 1 to cancel the negative, so dx is equal to negative du. Then, substitute to our given function. Limit of the integral of dx over the quantity of 4 minus x squared from a to 2 as a approaches to negative infinity is equal, since dx is equal to the negative u, we substitute the value. So, negative du over 4 minus x is our u, so u squared is equal to, so we take the integration of this function. But first, we need to reciprocate this to be the u, our numerator. We put the negative sign to the outside of the integration and reciprocate the given function. Limit of the negative of the integral u raised to negative 2 du from a to 2 as a approaches to negative infinity. So, we have the limit of a approaches to negative infinity, negative, the integration of u raised to negative 2 is equal to u raised to negative 2 plus 1 all over negative 2 plus 1 from a to 2. So, let us simplify the function. Is equal to limit of a approaches to negative infinity, negative times u raised to negative 2 plus 1 is equal to u raised to negative 1 all over negative 2 plus 1 is negative 1 from a to 2. And then we get the reciprocal of u raised to negative 1 over negative 1 to make the exponent positive. So we have limit of a approaches to negative infinity, negative times negative 1 over u from a to 2. And then, let us substitute the given limit. So, we have limit of a approaches to negative infinity, negative times negative 1 over 2, the upper limit, minus negative 1 over a, the lower limit. And then, let us substitute the value of u, which is u is equal to 4 minus x. Limit of a approaches to negative infinity, negative times negative 1 over 4 minus x from a to 2. And then, substitute the given limit. So, we have limit a approaches to negative infinity, negative times negative 1 over 4 minus 2, the upper limit, minus negative 1 over 4 minus a, the lower limit. And then, use the distributive property. So, we have negative times the limit of a approaches to negative infinity of negative 1 over 4 minus 2 minus the limit of a approaches to negative infinity of negative 1 over 4 minus a. And then, let's simplify. Is equal to negative times the limit of a approaches to negative infinity, negative 1 over 4 minus 2 is equal to 2 minus the limit of a approaches to negative infinity of negative 1 over 4 minus a. And then, we have negative times limit of a approaches to negative infinity of negative 1 half is equal to negative 1 half minus limit of a approaches to negative infinity of negative 1 over 4 minus a. Since a approaches the infinity, we take this value of 0. And then, we have negative times negative 1 half is positive 1 half. So, the function is convergent since it has a finite value. Example, we have the integral of e raised to negative x dx from negative infinity to 0. First, we have to convert this integration to the limit. So, we have limit of the integral of e raised to negative x dx from a to 0 as a approaches to negative infinity. And then, let us integrate the given value. Let u is equal to negative x and du is equal to negative dx. Divide both sides by negative 1 to cancel the negative. So, dx is equal to negative du. And then, substitute it to the given functions. The limit of the integral of e raised to u times negative du from a to 0 as a approaches to negative infinity. And then, let's put the negative sign outside the integral. Is equal to the negative limit of the integral of e raised to u du from a to 0 as a approaches to negative infinity. And then, let us integrate the function. We have negative limit of and then we have to integrate the given function. We have negative limit of a approaches to negative infinity of the integration of e raised to u du is e raised to u from a to 0. And then, let us substitute the value of u, which is negative x. So, we have negative limit of a approaches to negative infinity of e raised to negative x from a to 0. And then, substitute the given limit. So, we have negative limit of a approaches to negative infinity of e raised to negative 0 minus limit of a approaches to negative infinity of e raised to negative a. And then, simplify. So, negative limit of a approaches to negative infinity, e raised to negative 0 is equal to 1 minus limit of a approaches to negative infinity of e raised to negative a. And then, we have negative this function is equal to 1 minus this given function. Since a is approaching to negative infinity, this function will be 0. Negative 1 minus 0 is equal to negative 1. And it is a convergent because it has a finite value.